All right, welcome everyone. So welcome to part 2 of today's lecture. So I'm going to be going through the Land PKS app with you. I'm going to focus more on the soils parts of the app because I know that's something that was interesting to a lot of students. So I'll walk you through those parts, kind of give you a little bit of a background, but do feel free to download the app, play with whatever modules. I'm more than happy to answer any questions because I know this app really, really well, obviously having worked on it and helping design it for 2 years. So here's the Land PKS app. Just ignore the other apps that were on my phone. So these are all the places where I've done Land PKS. Most of these are actually in Africa. And that's one thing about Land PKS is it is cloud-based. So all of these locations that I've collected data at, they're all stored in the cloud. So even if you get a new phone, you can log in and it pulls down all of your data. So if your phone gets stolen or lost or broken, your data is not lost, which is very, very helpful, obviously. So we're going to start a new site. But before that, I just want to point out a few things. So you have the home button, map if you want to see the map, soil ID we'll talk about, climate, and then more. So one feature I did want to point out, if you go to settings, you can change the language. So the app is translated into 4 languages. You have, English, Spanish, Swahili, and French, which really was important for us to do because this is a global app. So you can use, the app in all 4 of these languages. I'm just going to stick with English. And then another thing you can do is you can use the metric system, which is what most of the world uses, or the English system for units, which is what America uses, the US uses. So I'll change it to English as that's probably what you all are more familiar with. So I'll go back to home, and to start a new site or to collect new data in a location, you click this plus button that's at the very top of the screen. So I click plus, and it actually uses the GPS on your phone to find your latitude and longitude, and you can see this location accuracy. It's getting better the longer I let the GPS kind of run. So it's within 14 meters right now, which is pretty good, actually. 8 meters, especially for being, inside my house on a rainy day. So I'm going to use the GPS to 8-meter accuracy. So I'll just click Use GPS. There you go. Site name. So let's give this one Home Office. Obviously, when you're actually collecting real data, today I'm just going to walk through how you collect data. When you're collecting real data, you're outside, you're digging in the dirt, you're actually outside collecting data, where today we can't really do that. So I'm just going to be collecting data in my home office or putting in, kind of explaining the process to you all. So site name, position, that's all you really need. So I'm going to click Save. So right now this is communicating with the cloud. So it's saving the site up in the cloud, and it's also drawing down information from the cloud. So here's our site, Home Office. Basically, there are 2 different screens. There's the report screen, which is what we're on now. And this is basically your data output. And then you have your data input screen. So the one thing I want to mention on data output first is the soil ID function here. So this is basically pulling down data from global soil maps, and it's telling me what, based on these global soil maps, what kind of soil I most likely have. So this app is ranking Reading as rank 1. And you can see the different soil textures. There's the key down here for the different soil textures, which are really important to know if you're doing agriculture or even conservation work. So you can even get more information. You can click on Reading, and it tells you, this is pretty technical stuff. It tells you, the scientific taxonomy. It tells you a little bit about the description. So the Reading series consists of moderately deep to Durapan, well or moderately well-drained soils. Something about the slope. And it gives you what the texture is most likely. So it says where I am here, the top 3 layers, or from 1 down to about 50 or 1 down to 20 centimeters, is a loam. And a loam is kind of a mixture of soils. That might be a mixture of sand, clay, and silt, which are the 3 major soil classes. The soil color, which can be important for understanding what kind of minerals are in the soil, and obviously important for plant growth. And then rock percent is also important. This is fairly high, 26% rock fragment, and that can cause issues for root growth, or let's say you're tilling the land with a tractor. You have a lot of rocks there, that's going to cause some problems for your equipment. This is giving sand percentage and clay percentage. So this is just some basic information for those who want to get a little more technical. The important thing here is you can see that under my soil on the left-hand side of the screen, there's no data because I haven't entered any data about my soil right here. Once you go back and enter data, then it'll re-rank these soils based on the data that you put in. So it'll use both your location and your soils data to give you an idea of what kind of soil that you have. This feature is incredibly complex and really unique. There are no other tools that I know of that do this, not even close. So this is what, honestly, we spent a lot of time on about a year and a half ago, is working on this feature, because combining both the soils maps data with what you're actually seeing below your feet is really, really powerful as far as predicting what type of soil that you have. What type of soil you have is going to predict vegetation type, the land potential, the land capability classification, and which we'll talk about. So that's really, really important there. So I'm going to close the soil ID. All right, so for data input, so what I'm basically going to do today is populate this land info bar, and I'll explain that as we go, and then this land capability classification bar. So we're going to populate those two, so we have data enough to get results for those two. So I click over to data input, and you can see it's broken out into the same kinds of modules. So here we have land info, land management, which is the agricultural record keeping tool. Feel free to play with that on your own. Soil health, land cover, and a few other things. I'm really going to focus on this top part here as far as land info. So I go and click on land use. So as I mentioned before, this app was originally designed to be used by farmers in Africa. So we've tried to keep things as simple as possible as far as data input goes. That got progressively more challenging the more technical types of data we're collecting, but we did try to keep it as simple. So this serves as basically a kind of a warm-up screen, to be honest. So you look, land cover, you're standing in a location outside, you look around, where am I? What does the scenery look like? So I'm at my house in Mira Mesa, so I'm definitely in an urban environment. So I'm going to go with village or city. And then grazing. Are there any animals that graze that land? Which is important to know as far as, what kind of habitat you want, or maybe what kind of habitat there is, as well as how that land's being used. Having animals graze on the land does impact the ecology, obviously. So at my house, we don't have any of these. So I'm going to go with not grazed. Then you can click back, and then back. All right, so land use we already filled out. Land slope. So this is really interesting. The slope of the land matters a lot, particularly when it comes to soil erosion. So if it's raining a lot like it is today, how is water moving over the land? So in my house, it's relatively flat. So I'm going to click on this first one here. So it's 0 to 2% slope. This is something you can eyeball if you want to eyeball, or you can use the slope meter here, which doesn't really show super well, but as I tilt, you can't see this, but I'm tilting my phone, and it tells me what my slope percentage is. So I'm just going to get out of that. I don't want to use a 200% slope. I want to use flat, because that's what it is. So slope shape is also really important for understanding how the water is going to move across the landscape. So once again, I'm in a very flat piece of land. So I'm going to go with linear and linear. The shape both down the slope and across the slope is basically flat. There's really no slope at all or no curvature to the land right here. So I go back and back. We've already entered that. Okay, so soil texture. This one is really kind of the meat of this app. So you go to soil texture. One thing that it doesn't really say on the app, but you do have to dig a soil pit. And this is probably actually one of the hardest aspects of using Land PKS, because you do have to literally get out a shovel and dig as deep of a soil pit as you honestly can. So the lowest layer we have is going down 47 inches, which is a lot. And depending on the type of the soil, it can be easier or harder to dig the soil pit. So if any of you are going a little stir crazy at home and want to give this a try and have a yard and a shovel, feel free to go ahead and try this out. Dig your soil pit. This app was really designed for minimal amounts of equipment, right? So most farmer anywhere in the world is going to have something to dig with. That's a pretty basic tool. And then this also does require some kind of measuring stick, and you can use a ruler, you can use a meter stick, you can even draw lines onto a stick that you cut off of a tree. So it doesn't involve a lot of technical equipment to use, which is really, really important. So basically for each depth, it's going to ask you two questions. What's the texture and what's the rock fragment volume? So let's say you don't know anything about soils. You click on the question mark and it tells you what rock fragment volume means. And we've put these question marks all over the app because this is meant to be used by non-soil scientists. So it's really important that people understand what these different terms mean. When I started working with Land PKS, they had no explanations and no question marks anywhere. And it was really confusing for myself, who was relatively new to the field of soil science. So I've really pushed the soil scientists that I was working with to include this kind of information, because if this is really truly going to be usable to the average person, it's obviously incredibly important that it's understandable. Okay, so let's say you've dug up your soil, just like that video I showed earlier. You've kind of filtered it. You're looking at it. So let's say rock fragment volume. Let's say I have basically no rocks. And these are little tiny pieces of gravel. These aren't big rocks. These are the tiny rocks, right? So no rocks. And then for texture, if you're an experienced soil scientist, you can just pick which one you think it is. However, that's really tough. So instead of doing that, I'm going to go press this Guide Me button right here. So does the soil form a ball? This question mark has this awesome video which explains how to do that. So you take your soil sample, you wet it, you try to roll it into a ball or not. Pretty self-explanatory. So does my soil form a ball? Yes. This is kind of one of those keys to determining the soil texture. Does the soil form a ribbon? That's what that one shows. So let's say that it does. So basically, the soil form a ball, the only soil that won't form a ball is really sand. When you're at the sea or at the ocean, sand doesn't really stick together very well. So sand does not form a ball. As far as the ribbon goes, the ribbon tests are really about clay. So how much clay is in the soil. The more clay, the more easy it'll be to form a ribbon. And then the longer that ribbon will be. So that's the next question, is the length of the ribbon. So you just, and this picture always cracks me up, you just measure the length of the ribbon, basically. So let's say our ribbon is between 1 and 2 inches. And then soil feel. So you take your soil sample, put it in the palm of your hand, wet it a bit, and rub it around. Does it feel gritty? Does it feel smooth? Or is it kind of somewhere in the middle? Not really gritty or not really smooth. Obviously, the grit is the sand. So let's say ours is gritty. So this then gives the texture at the bottom there. You can see it's a sandy clay loam. So use this texture. Great. So you can see on the left-hand side, the different depths. So we have our soil sample from 0 inches to 1/2 inch, and that is a sandy clay loam. I then click 1/2 inch down to 4 inches. So you really just repeat the same process. So let's say here there's a little bit more rock. The soil, yes, still forms a ball. The soil, yes, still forms a ribbon. It's still between 1 and 2 inches. And it's still gritty. So it's still going to be a sandy clay loam. Use this texture. We go down 4 to 8 inches. Let's say we're still at 1 to 15%. Yes, the soil forms a ball. Yes, it forms a ribbon, but now the ribbon is greater than 2 inches. And it's a little bit less gritty. It's somewhere in the middle. So now it says that this is a clay. I'm going to do a few more layers. So let's say we're still at 1 to 15. A ball. You can see once you get used to this, you can do it relatively fast. As I said, it's really the digging of the soil pit that is really, really time consuming. Length of the ribbon. And now let's say that it's smooth. So it's a silty clay. And one more. Yes, yes. Let's go with smooth again. So a silty clay. All right, so here I've collected some data. Let's say I could only dig down to 28 inches because I got lazy and stopped digging, or because that's as far as I could go. That's all I had time for. Obviously, the more data you collect, the more accurate your results are going to be. Also, you might hit bedrock. So if you go down here and you literally are digging and you hit rock, you can say, I hit bedrock. So let's say that we did. We hit bedrock. Oops, nope. 27 inches. Let's say we hit bedrock. Okay, so now I'm going to go back. The next one on here is the soil limitations. So these are really important for determining the land potential and determining the land capability classification. So it just basically asks you these questions. Similar to the soil texture, you don't need any fancy tools or anything to answer these questions. So the first question it asks you is vertical cracks on the soil. So I'm going to go ahead and click the question mark. So this even provides a picture for you. What do these deep vertical cracks look like? Is it very, very cracked, or is it kind of just that surface cracking that you might get sometimes? So let's say no cracking, surface cracking only, or deep vertical cracks. Cracking can be important for plant growth, obviously. If the soil cracks, that's going to impact root growth. If the soil cracks, then the roots who are in that soil, might also crack as well, or basically be broken apart. So that can cause some issues there. So I'm going to go with no cracking. Salt on the soil surface. So this is our attempt at drawing what salt on the soil surface looks like. Obviously, having a lot of salt is an issue with plant growth. Most plants can't tolerate high levels of salt in the soil. So I'm going to say there are no salt. Okay, flooding. So these are just the different categories that it gives you for flooding. This is a pretty apparent one for why it's an issue, but for most crops, too much standing water is an issue. It means the roots can't breathe, and it's going to cause a lot of issues for plant growth. We're very frequent. You can see at the bottom it says prevents normal production of crops. So I'm going to say, because we do have some standing water in my backyard, I'm going to go rare to occasional. So lime requirements. This is really trying to get at measuring pH. The pH of the soil is important for plant growth. It's important for how and if the soil can hold fertilizer well or not. So one thing that many farmers do is add lime to the soil to raise the pH to make it an ideal pH for crops. Because a low soil pH or a high acidity is going to be a problem for many crops. So does my soil require lime or not? Based on how I've seen things grow in my neighborhood, I'm going to go with it does not require lime. This is one of those questions that can be a little bit challenging, and it's something that you can always leave blank if you don't know the answer to be honest, that's okay. Surface stoniness, we have these nice pictures here. So this is the same problem. As far as rock magnet volume, if there's a lot of bigger, and this deals with the bigger rocks and boulders, if your land is basically 50% rock, that's going to limit if you can do agriculture on that land. So my backyard has a decent number of rocks in it, so I'm going to go with 3 to 15%. Water table depth, so this is something you might have to guess, or let's say you dug a hole and you hit water, then you're going to know exactly how deep your water table is. But let's say I dug my hole, I never got to any water, so it's at least greater than 48 inches. I don't need to know exactly what it is, but it's at least greater than that. And then soil depth. So I did hit bedrock, or I put in that I hit bedrock at about, 28 inches. So this is going to limit, what kind of trees and plants can grow there, because if their roots can't go deeper than 28 inches, then that's going to be a problem. So we filled out all of these. I'm going to skip soil color for now because that one is a bit complicated and you actually do need some specialized equipment for that, which I don't have. So the other one I just want to kind of mention down here is the soil health. This also has to do with soil, and this has to do with more of the dynamic properties of soil. So a lot of the things that we classified up here, these properties of soil, land info, they're things that aren't really going to change very much from day to day. There's things that are going to be true about the land for long periods of time. Soil health is a little bit different. So just to walk through this is more of a calendar-based thing because I said things can change over time. So I click today. And these are the different categories that you can look at. So you can do field observations, so things like we were just doing, which are a little bit less technical, or you can do actual soil tests. If you have the equipment to look at the exact organic carbon, pH, or electrical conductivity. And all these are really important for knowing kind of the fertility of the soil. So some of these we can do. So I'll do biological activity. Is there a lot of biologic in here? You can look at the question mark. So the 1, 2, and 3, none or little sign of organisms in the soil. 2, some living organisms in the soil. Or 3, many signs of organisms in the soil. So this is things like worms and kind of other just things that should normally live in your soil. So I'm going to give this a 2 because I have seen plenty of worms in my backyard. Soil smell. Does the soil smell fresh, sweet, earthy smell, little or no smell, or swampy, stagnant, or mineral smell? I'm going to go with fresh. Erosion. These are just different patterns of, different kind of signs of erosion on the land. So water flow patterns. Don't see any. Rills. So rills does give a definition of small intermittent water courses with steep sides, usually only several centimeters deep. So those are those like little lines that you'll see on the side of a slope that show that a water has been, moved through that area. So I'll go with none. There are no big gullies in my backyard, so none. All right, I'll just stop there for now because I just wanted to show you what kind of things you could do, and then you can monitor this over time. So let's say every year you'll go out on your farm, you monitor these things, and then you can see how it changes over time. Does erosion getting better over time or worse? What does the biological activity look like over time? Is it changing? This can kind of tell you how those land management decisions that you're making are impacting the quality of your soil and the quality of your land or the potential of your land. All right, so we've entered a bunch of data. So let's go back. Before I go back, I guess, synchronize now. I'm going to click on that because that's telling the phone to send up all my data to the cloud. So it's basically saving my data to the cloud. We have a special button because let's say you're in Africa in a small little village and don't have good cell service, you don't want your phone to constantly be trying to find service and be trying to find the cloud, because it's not going to find it. So that's a way you can, control when you talk to the cloud and when your phone talks to the cloud and the databases and algorithms that we have up in the cloud. Not so much of a problem in the US, but it's actually still surprising what kind of places you can go where you don't have great cell service. Maybe less so in California, but in other places definitely. So now I'm going to go back to report. So open up my land info. So now we have some data. So here it has AWC estimated to 8 inches and AWC estimated to 40 inches. So what the heck is AWC? That stands for, if I click the question mark, available water holding capacity. This is really, really, really important because it basically says how much water can your soil hold. And that's important for plant growth. If your soil cannot hold that much water, it's going to limit what kind of plants that you have on your land, limit what you can grow, but also limit kind of just the natural vegetation. If plants that require a lot of water are not going to naturally grow on that land. So it's going to kind of really influence what kind of ecosystem you might have. And there are things you can do to change that. Is, for example, adding organic matter. So this organic matter piece down here, we didn't measure organic matter, but this allows you, if you move this back and forth, to look at how adding organic matter might change the available water holding capacity. So that's really interesting right there. Surface infiltration rate is also really important. That basically says, does the water actually soak into the soil or does the water run off? You generally want your water to soak in, right? That it's in the soil ready for your plants to use. If it just runs off, that can cause issues with erosion. It means that, it's just moving downstream, down into the rivers, and it's not usable for plants. And then this records your soil texture by depth. So you can see the different textures we put in and the rock fragment volumes. So that's fairly simple. Where it really gets interesting is that this land capability classification here. So as I explained, land capability classification a bit, it classifies your land into land that's usable for agriculture or land that actually would be better off set aside for conservation efforts. This is really, really important because if you are trying to decide on where you want to put your farm, you want to not take all the time and effort to clear this land and then have it be not so useful for farming. It would be much better to leave it as it is, as the forest, as a grassland, because it's going to be actually more productive that way. So this is a really important tool that's being used a lot, especially for land use planning. So determine, where to put conservation areas, where to maintain those natural ecosystems, and then where you should put cities and farmland and things that are actually going to be sustainably productive. So this is really where those conservation benefits come into play. You're preventing land that is not sustainable for agriculture from being converted into agriculture, maybe used for a year or two, and then just left. So that's really the conservation benefit here. So as I showed in the PowerPoint, this gives you basically all the information about what the classes mean. So the land capability classes 1 through 8. It also gives you the subclasses. So it looks like we scored a 3. So just in general, this is severe limitations that reduce the choice of plants or require special conservation practices or both. So based on the data I put in for my house, this land can still be used for agriculture, but you might have to only grow certain types of crops that are suitable for this soil, or you might have to do some conservation practices. So what that really means is you might have to conserve water in a certain way or another. Maybe you dig some canals to help keep the water on your land, or Maybe it means that you have to do some terracing, or maybe it means, something like that, adding organic matter. You have to do some kind of soil, but basically this means soil or water conservation practice on your land. The app doesn't tell you exactly what you should do because this is a global app. You can't give the same recommendation in the US that you would maybe give in Tanzania. There are different kinds of conservation practices that are commonly practiced, and different kind of crops that are planted, different kind of food that's eaten. So we don't get specific into what exactly you should do, but this tells you that you should do something. So for the subclasses here, we have 4 different subclasses. So basically, you can look these up in this question mark if you want to, or you can come down here and you can just visually look at it. So which of these categories received a 3? There are 4 of them. So we have soil depth, which means that the depth of the soil is a major limiting factor. We hit bedrock, right? On our pretend data, we hit bedrock. Surface stoniness, so there are some stones, so that's going to be a limiting factor for agriculture. Soil water storage capacity, so it holds water, but not as much as it could potentially. And then permeability, so that's kind of more of that surface infiltration rate. So the water doesn't just soak up into the soil, it runs off quite a bit. So some of these we can control and manage for, and some of them we can't. So for example, soil depth. It's really quite hard to make the soil deeper. That's something we probably can't change. However, soil water storage capacity and permeability, we could potentially change. So for example, by adding more compost or organic matter to the soil, that's going to increase our soil water storage capacity and increase our permeability. So you can always go through and click on all these different question marks, but these basically tell you the capability of your land and then why it got that score. So we got a 3, and why did we get a 3? Because of soil depth, because of surface stoniness, because of soil water storage capacity, and because of permeability. So on my land, those are the challenges that I face. And that is really useful information for the farmer. So you can see as how this is kind of the kind of citizen science project I was talking about the other day that is really meant for helping people make decisions. So now that I know this information about my land, I can manage it differently in order to meet my needs. So that's land capability classification. This is really, really useful, and this is something that I spent a lot of time working with the Tanzania government and working with the Ethiopian government to implement in their land use planning offices, because in Tanzania particularly, they don't do a biophysical assessment of the land when they're planning village land. And that's obviously not great because you need to know what the land's capable of to know how to plan out the land. Like I said, where do you put the farms? Where do you put the forest reserve? Where do you put this? This can really help you quite significantly. Obviously, the locals who live there have their own local traditional knowledge as well. And this is a way to complement that as far as providing, okay, yes, you're right. The villagers know the farm should go here because of X, Y, and Z reasons. This is a way for an actual kind of land use planner or surveyor to go out and very quickly and cheaply survey the land. As I said, no technical equipment, really just need a smartphone. And you don't need to have these highly trained personnel to go out and do this. You can train people in a few days and they can go out and do this themselves. So this is a really useful tool in land use planning. In Ethiopia, we spent time working with them because they actually have a much more detailed land use planning process, but it's all paper-based, and paper gets dirty, paper gets lost. You have to input data from this paper. So they were actually there testing out if the paper-based process was easier or if this process was easier. And there were kind of some mixed conclusions, and I left the project right as this was happening. I left the PKS project, so I'm actually not sure of the results. But this is really where this tool is useful as far as cheap, efficient, easy land use planning, which can benefit both people and can benefit the environment by choosing smartly about what you do with your land. So the last thing I want to go to is the soil ID. So now we've actually entered data. So this is based on the GPS ranking. So we have that Reading soil. If I click on data, that ranks it basically just based on the data that I put in. So it still ranks it as a Reading soil. If I use both, it still ranks it the same. So in this location, it basically says that my soil maps and the data that I put in are fairly consistent. Soil maps are often really just guesstimates of what kind of soil you might have, which is why it's really important to actually dig a hole and see what you might have. Soils can change very quickly on the landscape. It's not like all of San Diego is one soil. There's probably hundreds of different soils in San Diego. So this is a way to actually kind of look at that. All right, so that is my very kind of basic tutorial for Land PKS. As I said, please download it and play with it. The land cover one is one we didn't go over, but that's particularly useful if you're managing vegetation and seeing what kind of vegetation is on the land. Land management, let me just dig into this one for a second, but this is similar. Let me go to the data input. This is very similar to the soil health, where you actually have dates and you enter in data on those dates. So let's say today on my farm, I irrigated. You can enter in data like that and then track your data over time, which helps you, kind of learn more about your farm practices, what you're doing right, what maybe you should change. So really all of these tools in the Land PKS app are really about collecting data about your land, which, like I said, it does go up to the cloud, it gets stored, it gets aggregated in our data portal, so it can be available for other people to look at. But really the primary purpose is to have it available for the users. I enter data about my land because I want to make better land management choices and better land use planning choices. I'm not entering this data for other people most of the time. So that is Land PKS. Now, one thing I didn't show on the bottom here, you can click on climate, and this will talk to the cloud and fetch the climate for your area. So this is for where I live. We're in March, one of the rainier months, which is what it's showing. You can show temperature throughout the year, approximate elevation, and these are all estimates because this is not an exact pinpoint. This is based on a gridded kind of map, but these are all going to be fairly accurate for where I am, I would say. The other thing is the map function will show you all the different places that you collected data. So you can see this is where I live, up in Mira Mesa. Here at the university, you can see I've done Land PKS a few times at San Diego State. And then most my other sites, some in Colorado, because this is where I was living before I moved to San Diego. And then I have probably a bunch in Africa. This is where I've mostly worked. So quite a few in Tanzania, in Malawi. None of my Ethiopia stuff was saved. So this is some of the places where I traveled to give demonstrations of the app. And it was really quite interesting, doing this with farmers and with ag extension agents and with land use planners and conservationists, and just kind of getting their reaction, because a lot of them do have smartphones, but they really only use it for, texting, phone calls, WhatsApp, Facebook. They're not using it for work. And as we know in the US, more so, there are apps basically that do anything and everything. So the thought that they could use an app on their phone to help them make important decisions in their job was really quite, it was really quite nice to see, and really quite kind of mind-boggling for these folks. So don't think I have any other ones. That's basically it. So that is Land PKS. Thank you for your time, and I will be posting the participation to Blackboard, or it probably is already posted. So I will see you on Monday again. Thank you.